Today we're going to be talking about the substitution method. Okay, so last video we reviewed on how to graph a system of equations, but now we're going to talk about maybe if you don't feel like graphing, or maybe if your coordinate grid gets too big, you want to do something called the substitution method. Okay, so let's start off with number 5. So let's talk about what this line means. As you can see, each problem has this sort of squiggly line. That is telling you that this is a system of equations. These two equations both lie on the same coordinate plane. Okay, so we're trying to find out, we're trying to figure out if these two lines intersect, they don't intersect, or how do they connect with one another. Okay, so looking at number 5, we have y equals 2x plus 3 and y equals negative x minus 9. So we're going to see if these two equations intersect, if they have one solution, or they do not intersect at all, or maybe they're the same line. Maybe they're the exact same line and every point will overlap one another. Okay, so with the substitution method, I have our steps right here. So what we're going to do in step 1, it says solve one equation for x or y. So let's do that first. So I'm going to do the first equation. So I'm going to solve this for an x or y. Well, if we look at this equation, it's already solved for y. So we're going to substitute y equals 2x plus 3. So we're substituting in for y. So this one is already solved for a y. But if it was, say for instance, anything else, let's say for example number 6, 2x plus 3y equals 4, or y equals 5x minus 27, you would have to decide if you wanted to plug in this y, or if you wanted to solve this equation for x or y. But luckily enough, this one is already solved for y for us. Okay, so now it says step 2, substitute this expression into the other equation and solve for the variable. So we're going to substitute this back into our second equation. So we have y equals negative x minus 9. And then we have to look what we already solved for. So we already solved for y. So now I'm going to replace this y with our first equation. So we're going to substitute in this y for 2x plus 3 equals negative x minus 9. And now you can see that we only have one variable now. So now we can use this system of equations to solve for x. Okay, so I'm going to bring my x's on one side. So in order, remember, if you want to bring something on the other side of it equals, you have to do the opposite. So in order to move this negative x on the other side, I'm going to turn it into a positive x, or add x to both sides, because whatever we do on one side, we have to do on the other. So 2x plus 3x, remember we're going to put a 1 in here. So this is a review of combining like terms. So 2x plus 1x will become 3x. We bring down our plus 3 equals, now negative x plus x cancels out. So now we're just left with negative 9. Now we have 3x plus 3 equals negative 9. Draw our balance again. Now I'm going to move this 3 on the opposite side because we're trying to solve for x. We want to get the x by itself. So the opposite of adding 3 is we're going to subtract 3 from both sides. And we have 3x equals negative 12. Now remember, this is multiplication because they are combined together. So 3x is the same as saying 3 times x. And the opposite of multiplication is division. So I'm going to divide both sides by 3. And now we have x equals negative 4. Now looking at step 3, it says substitute your answer into the revised equation from step 1 and solve for the other variable. So we have x equals negative 4. And I'm going to plug that back into our equation we solved for, or you could plug it into either one. You should get the same answer. And we're going to solve now for y. So we have y equals 2x plus 3. And we're going to plug in our x value that we found. So we have x equals negative 4. So we have y equals 2. And we're going to put that in parentheses now. So we have negative 4 plus 3. And now we're going to solve for y. So we have y equals 2 times negative 4 will give us negative 8 plus 3. And y equals negative 5. So we now have an ordered pair. So we have x is negative 4 and negative 5. So this tells me that these two lines will intersect at one point, or one ordered pair of negative 4 and negative 5. Well, let's check that. So if we go to Desmos, we can use our graphing calculator. And we're going to graph our system. So we have y equals 2x plus 3, and we have y equals negative x minus 9. So we can see here that these two lines intersect, and we can check our work at the point -4, -5. So this would be one solution where our lines intersect at point -4, -5. So recapping, for the substitution method, you're going to solve one equation for x or y. So in this case, we already had a y value, so we could have chose either one. So we chose the first one. We said y equals 2x plus 3, and we're going to substitute that in to our second equation here. So we replace the y with 2x plus 3 equals negative x minus 9, and we were able to solve for our x value. We then take that x value and plug it back in to solve for our y value, and you can see here we got an ordered pair. Okay, so there's three types of answers you can get. One will be an ordered pair, one will be a no solution when the lines don't intersect, and the other one would be if the line is this exact same, meaning that they overlap one another. All right?